Do you know Marie Curie? This is not a video about her life. It's a video about some key terms to understand her work and about her science. Maria Salomea Skłodowska, commonly known as Marie Curie, was a Polish physicist and chemist. Let's not forget she was married to this guy, the scientist Pierre Curie. Marie Curie discovered and named the phenomenon of radioactivity. She also discovered two new chemical elements, radium and polonium, contributed to a new perception of the atom and matter, advanced the biological research for cancer treatments, and developed mobile X-ray units called Petite Curie's, which saved more than 1 million soldiers during World War I. Now, before getting into her work, we will talk about some key terms to make it easier for you. Start by the word element. It's any substance that cannot be decomposed into simpler substances by ordinary chemical processes. Elements are the fundamental materials of which all matter is composed. Now let's talk about pitchblende. It's a brown to black mineral that consists of massive uraninite, has a distinctive luster, contains radium, and it's the chief ore mineral source of uranium. And how does the Curie electrometer works? Once set in motion, the electric charges produced by the radioactive source move towards the quadrant electrometer. The electrometer then measures the electric charge. The quadrant electrometer is a long quartz fiber attached to a metal propeller-shaped component and a small mirror. The propeller is suspended between two circular metal plates, each of them separated into 4 quadrants. When the external electric charges, for example charges from ionization chamber, are sent into the electrometer, the electrical field varies and this makes the propeller turn slightly. To detect this small movement, scientists use the mirror attached to the propeller. A ray of light is projected onto the mirror, which reflects onto a ruler. When the propeller turns, the mirror turns along with it, and the point of light moves from over the ruler. By measuring this movement, scientists can determine with a high degree of accuracy how much electrical charge is being sent to the electrometer. And now, let's get back to her work. The Curie's were research workers at the School of Chemistry and Physics in Paris to study a phenomenon reported by Professor Henri Becquerel, whom reported that uranium emitted invisible rays. In February 1896, the French physicist Henri Becquerel noted that uranium salts could expose photographic plates without them needing to be charged by exposure to the sun. It appeared that uranium spontaneously generated a type of energy in the form of invisible rays called uranium rays or Becquerel rays. Marie Curie used a property that Becquerel had discovered. When uranium rays passed through the air near an electrical measuring instrument, he found that the instrument detected a difference. Marie Curie was lucky to have at hand just the right kind of instrument, a very sensitive and precise device, invented about 15 years earlier by Pierre Curie and his brother Jacques. As she measured the rays from different uranium compounds, she discovered that the more uranium atoms in a substance, the more intense the rays the substance gave off. Trying to see what was so special about uranium, she tested minerals containing other elements. But Marie noticed that the results she was getting from the pitchblende were more radioactive than uranium alone, therefore suggesting that there must be something else in the pitchblende. They crushed, dissolved, and separated pitchblende, obtaining a black powder 330 times more radioactive than uranium. They concluded it was a new chemical element and named it polonium with atomic number 84. And to finish her work, she discovered the liquid that remained from this extraction was very radioactive as well. Even though it was present in pitchblende in smaller quantities, it was more radioactive. They realized it was another new chemical element, called radium with atomic number 88. We hope you liked our video about Marie Curie's work.